Now we're recording. Good. All right, so welcome to Physics 1. Was this 1321? I can't remember what the names of the courses are. My name is John England. I'm the instructor for this course. Just call me John. I don't care about titles and things like that. As you guys that are online with me, as I've said in the emails before, that I'm giving you a lot of flexibility in this class. If you choose, you may show up in person when I record these lectures. My plan is to do Monday, Wednesday, and Friday from 1 o'clock until around 2, probably about 45, 50 minutes. I don't want to overload you with information in this course. I know that a lot of you are taking this course because you are probably not physics majors, you're probably not engineers, you're probably doing medical history, something like that. And I expect many of you are probably a little intimidated with the mathematics that's going to come up in physics. But that's okay. So what I do here, this is an algebra-based class, so nothing beyond some simple trig functions like sine, cosine, tangent are going to be required of you. My office is in ETAS in 300E. If you need to talk to me about stuff, and you want to be on campus, just let me know so I can make sure I'm in the office. If that doesn't work for you and you need a Zoom meeting, send me an email and we will work it out. This is the only class that I'm teaching this semester. My time is much more flexible than your time. So you let me know and I will adapt to you. The syllabus has a little bit of an error in it. It's not a big deal. In the syllabus, I talk about how I'm going to give 3 exams and I'm going to do the homework assignments. The syllabus verbiage talks about the homeworks being, or the exams being in class. That is not true. That those are all going to be online as well. I generally just cut and paste on my syllabi for the different classes, and that's kind of boilerplate language that I just missed for this class. So not a big deal. Homework assignments are going to be using WebAssign. If you have not used WebAssign before, the information on how to get to it is in the syllabus. There is a sign-up code. I suggest you get signed up and linked into there as soon as you can. There are no homework assignments for this week, but starting next week, there will be a couple. The homework assignments are going to be key to being successful in this class. You need to engage with them. I do not expect you to be perfect on the homework assignments, and I do not expect you to be perfect on the exams. I am going to challenge you. That's okay. Understand, grades in this class are more about me than they are about you. Grades, the way I do grades is it is a way for me to gauge if I am delivering the content and delivering the information in a manner that you can understand. Having said that, if you are consistently scoring mid-70s to low 80s on my exams, you're doing okay. So don't freak out if you end up with like a 70 or 72 on an exam. That's okay. At the end of the semester, when I go to post final grades, I'm going to look at the whole picture. I'm going to look at the whole student. I'm not going to go just based on what the grades are. Now, what that means is that I can look at your homeworks and I can see how long you spent on each homework assignment. So if I'm seeing your homework assignments are substandard and you're only spending about 10 minutes on each assignment, that tells me you're not trying. Tells me you're not engaging. If I look at your homework assignments and I see that you're spending about an hour on each assignment and you're showing me improvement, that's fine. That's okay. That kind of thing tells me that you're actually giving this effort and it's not a blow-off class. I don't like to be a prick about things. I can be if I have to, I don't want to. I'm ex-military. I spent 22 years in the Air Force, so if I need to be a hard ass, I will, but I don't want to do that. I'm going to treat you like adults. I expect you to keep up with the content in the class. That's okay. I understand conflicts are going to arise from time to time. You know, maybe you've got, you know, a dog dies or something unfortunate like that, or maybe you had a family vacation schedule that conflicts with something, medical issues, whatever. We can work that. Just let me know. Keep me informed of what's going on, and I will work with you to be successful in this class. The textbook is listed in the syllabus, and it is free. I don't want you guys spending hundreds and hundreds of dollars on basic physics textbooks. Again, all the information for it's in the syllabus, how you get to it. The homework assignments are linked to the electronic text. So if you've never used WebAssign before, that's one of the things that's really cool about it, is you can go in, attempt the problem. I think I have it set to where you get 3 attempts at each problem. And if you miss the problem, it will tell you in a link that it'll go, hey, you should go look at, you know, chapter 1.2 or something, whatever it is, for a hint on how to solve the problem. Again, if you're really, really struggling, let me know. Reach out to me. I'll help you. Not a big deal. As you might expect, I probably know a little bit more about physics than you do at this point. I have a degree in astrophysics. I have master's in education. I have master's in applied physics. So I know what I'm doing. It may not appear so sometimes. That's okay. But again, if you're really getting hung up, reach out to me. Ask. That's okay. Physics is a non-trivial discipline. There is a reason that you don't see 100 graduates every semester getting physics degrees. There's a reason this classroom is not packed with 100 students right now. It's okay. Just what was that Disney song a few years ago? Let it go. That's what you need to do. Not blow it off, but just kind of let it go. Just chill. So let me start. Excuse me while I play with the camera here. Oh, wait. I know it looks like a black hole right now, but I'm about to fix that. Oh, come on. Whale. Sorry, guys, I'm attempting to learn how to use this whole setup in here. And I am failing miserably. Let me see. Yeah, I know. Sorry, guys. This is new equipment for me. All right, let's see. You guys that are online, are you seeing my cat meme right now?
Yes, sir.
Yeah.
Okay. Let me see then. If I say stop share. And then I go to camera. What are you guys seeing now?
Nothing.
Yeah, nothing.
Okay, just got a gray screen.
Yeah.
Okay. Well. Now you probably see me, right?
Correct.
Sorry about that. That's not going to work either. Okay. Well, let's do something different so that I don't use a whole lot of time here. Go back to share screen. Okay, we should have a whiteboard now, right?
Yes.
Okay, cool. Man, I got to figure out how to do this for in class. So here's what I'll do for my one student that I have in the classroom right now. I'm just going to duplicate on the whiteboard when I'm drawing for you guys. And I'll have this figured out Friday. So let's first think about what it is we're trying to do here. What is physics anyway? Anybody got any ideas? I can see the chat log as well as hear you guys. So you can talk to me on either on audio or you can type in the chat. Either one is fine. So somebody give me an idea. Somebody give me a definition of physics. Nobody? Everybody's scared. All right. So let's talk about physics then. Let's talk about what that means. Physics is defined as the study of the relationship between matter and energy. That's really all we're doing. A shorthand version of that is it's the secrets of the universe. It really is. It's how do things work? So if we think in terms of everyday lives, for example, I drove down here to campus from Conway this morning, and it was raining. And of course, I have to be aware, and I have to think about the road might be kind of slippery, right? Because of rain, and those conditions are going to be different than if it's dry, and it's going to be different based on temperature. Well, those things are something that we kind of all think about, but we don't really do a lot of in-depth analysis in our daily lives. For us as users of the car, that's perfectly fine. But if I'm going to design the car, then I should be able to predict how that vehicle is going to behave based upon the road conditions, outside temperature, weather, that sort of thing. So we're going to encounter things in physics. We're going to encounter terms when we talk about that. We're going to think about things like friction. And we're going to think about things like mass. We're going to think about things like speed. Now, in order for us to talk about those kind of things, we are going to need a few tools. And we're going to need a standard language. So the language that we are going to speak, we are going to talk about something called standard units. Sometimes we call these SI units for scientific industry units. So we need to have a common language. And so when I say standard units, these are going to be the things that we usually measure things in, right? So if we're talking about something like a length, I can come up with lots and lots and lots of different ways that I can measure length. We all probably grew up in America, in the American education system, and we learned how to measure things in inches and feet. Well, everywhere else in the world, except for Liberia and one other country I can't recall right now, uses what's called the metric system. We tried to do this in America in the 70s for about 2 weeks, and then the teachers' unions went, yeah, it's too hard, we're not doing that. So we in the scientific community, though, since we're better and smarter than everybody else, we use metric as our standard units. So whenever we talk about length, we're talking about things in terms of meters. If we talk about time, we measure things in seconds. If we talk about mass, we talk about things in terms of grams or kilograms. So that's our starting point, is going to be SI units. So everything that we talk about, every answer that I'm going to expect of you on homeworks and tests are going to be in SI units. Now, just because I'm going to expect the answer in SI units does not mean that I'm going to give you the pieces of the equation that you need to do in SI units. For example, I may give you a question that deals with something in feet and ask you to give me an estimate of the distance in meters. So you're going to have to know how to do some conversion. So this is one of our first mathematics tasks in physics. If you are concerned about the mathematics of this course, think of it this way. Let's say that I'm going to build a house. One of the tools I'm going to need to build the house is a hammer. Most likely. Now, how many different kind of hammers are there? Lots. But I can generally pick out, if I go to Home Depot and I need to nail a couple of pieces of wood together, I can generally figure out that a standard claw hammer is probably going to be a better tool to use than a sledgehammer. Unless I'm really pissed off at building the house. So I need a tool to build the house. Physics is the house. Physics is the house I'm trying to build. I need tools. My tools are mathematics. So math in this analogy is the hammer. Algebra, calculus, that kind of thing. Algebra and calculus are two different things. Well, they're two different hammers. Sometimes one hammer is better to get the job done than the other. But in the end, I don't care as long as we build the house. So what we're going to do in this course is everything's going to be algebra based. But we are going to use that algebra based hammer. But occasionally, I'm going to show you some calculus things. I'm not going to hold you responsible for them on exams, but I want you to have a little bit of a preview of where this goes. Surprisingly, when we do physics problems, it usually is much, much more difficult, or at least more tedious to get to the answer if you use algebra. There are things that I'm going to show you how to calculate that might take 5 or 6 lines of calculation to do with algebra. If I use calculus, I can do them in 1 line. Way, way more efficient. Again, I'm going to show you tricks like that. I am not going to hold you responsible for them because I cannot assume that you guys have had calculus or were very successful in it the first time you took it. Maybe you are, and that's okay. And if you know how to do some of the stuff using calculus, and you give that to me on the exam, that's perfectly fine too. So what we're going to start with is an exercise in unit conversion. And I'm going to show you some tricks, some things that are actually going to be pretty easy. That's not what I wanted. There we go. So let's say, just for the sake of argument, that I have something that is, I don't know. I'm having to do this with my touchpad mouse for you guys that are online. So let's say I have something that is 10 feet long. Well, that's cool if I'm working in imperial units, called freedom units, right? But that's not good enough for my physics problem. So I need to get this into meters. Well, the thing that I need to know is a conversion factor. I need to know how many meters there are in a foot, or how many feet are in a meter. Well, how am I going to know that? Some things you're just going to kind of know, right? You probably know there's 12 inches in a foot. All right. In fact, let's do that. Let's say we don't know how many meters are in a foot. So we're going to start with what we do know. I know how many inches are in a foot. So I'm going to do a little unit conversion here. Now, the easy way to do this is to set up a multiplication. So we start with our 10 feet and we're going to multiply it by something. That something is going to be a fraction. Imagine that's a straight line. Now notice that my units are in feet. I want the feet to go away. So the thing I want to go away, I put on the bottom of my fraction. The thing that I want to turn it into, in this case, inches. Oh, I hate touchpads. Goes on. So I'm setting up this pattern in this tool for doing unit conversions. How many inches are in a foot? Well, we know that. You know there are 12 inches in 1 foot. Damn. All right. Tell you what, let's do this text. Bam. Let's go 12 for 1. Okay. So no, there's 12 inches per foot. Notice when I do this, come on. Notice when I do this, just using my standard fraction rules, be canceled. And so what I end up with is something that looks like 10 times 12 inches, which gives me 120 inches, right? Well, if I have 120 inches, I'm still not done, right? Because I need this thing in something called meters. So I need to know how many meters there are in an inch. So we can set up a similar kind of thing. We have a fraction. We have inches, right? We want inches to go away. So we're going to multiply that by some fraction. And in this case, I'm going to put centimeters on top and inches on the bottom, because I happen to know that conversion. I happen to know that there's 3 centimeters in 1 inch. So we're going to fill in the values there appropriately. So what are we going to get? Again, just doing basic fraction math, your inches are going to cancel. You're going to end at 120 times 3 centimeters. That should give me 360 centimeters. Aha, now we're getting somewhere. I'm not done yet though, because remember, I want this in meters. So what do? I set up another fraction. I want centimeters to go away. So I want the centimeters to be on the bottom, and I need meters to be on top. I happen to know that every 1 meter is 100 centimeters. How do I know that off the top of my head? Well, because I am the big brain. Now, it's because I understand and use these prefixes. So centi is something that we're probably all familiar with. Centi means 100, right? Milli is 1,000. So we'll get things like millimeters would be 1,000 millimeters. Kilo is again 1,000. So milli are going to be the small units. Kilo are going to be the 1,000. So 1 kilogram is the same as 1,000 grams. So just be careful with which one you're converting to. But if you use this little kind of fractional notation, I think this helps a lot with unit conversion. So if we carry on with our little fractional exercise here, what we get is we'll notice that centimeters on the bottom cancel. But now my math is a little different because of where my numbers are in the numerator and denominator. So what I end up with is something that looks like 360 meters. Whoops. Yeah. Divided by 100. Notice that I got rid of the centimeters, so I'm left with just a number on top of something with a unit. So 360 divided by 100 Gives me what? Should be easy. 360 divided by 100 gives me 3.6 meters. Oh, interesting. There's my answer. That's what I asked, right? That's what I wanted to know, was how many meters is the same thing as 10 feet. So 10 feet is about 3.6 meters. Now I say about. Let's talk about decimal places. Yeah. No. In the wrong place. It's all right. What room are you looking for? L. No, this is the physics building. You may be looking for Fairburn Hall next door. Yeah, it's one next door. Yeah, no problem. So we up to this number that's 3.6 meters. Now, most of the time, that's going to be okay. I can certainly measure something with more precision than that. So let's say I had something that I said, oh, it's 3.6 meters. If I had more precise measuring tools, for example, some kind of laser measure, I could certainly write this down to 3.6, 9875, however many decimal places you need. It's a little bit of a trick, a little bit of a skill in physics to understand how far out you need to go. Generally, I am only going to ask for maybe 2 decimal places of precision. In this case, because this was such a precise calculation, the way you do that to 2 decimal places of precision, you do 3.60. The things that I'm going to give you and the things that I'm going to ask you to calculate, like I said, are generally going to be to 2 digits of precision. So on the homework problems, since they are automated, sometimes it is going to kick back an answer to you because you're not within whatever tolerance that it is looking for. So if it's looking for a tolerance of 0.05 and you write an answer that's 0.06, in the right place. Which class are you looking for?
Science of finance.
That is in Fairborough, the next building over.
Oh, okay. Thank you.
Yep. So we're looking for 3.60. So again, 2 decimal places of precision. Now that last decimal place, that 0, notice that it's kind of meaningless. But again, you're going to come up with problems sometimes in the homework that are going to look for an answer in the system like 3.65. And that may be the tolerance it wants. So if you give it something that says 3.7 and you're rounding up, sometimes the homework thing is going to tell you you're wrong. I take that into account. When I go review what you've done on the homeworks, I can see that. I can see where you were wrong by, a 0.05 or something. You're in tolerance. That's okay. You're going to get credit for that. Don't worry about it. Again, the homework assignments are there for you to practice this stuff. Now, how important is it in the real world that we get this precise? It depends on our application. Those of you that are in nursing, if you give somebody an injection of insulin, let's say, I don't know what a standard dose of insulin is, 0.2 millimeters or something, I don't know, cubic millimeters, I guess it would be. what's the difference between giving somebody a dose that's 0.3 and 0.5? Depending on what it is, it could kill them. So for that application, you'd need to be more than 2 decimal places of precision. If I'm launching a rocket to go to the moon, and I know kind of how far away the moon is, and I can do trajectories and orbits and things, which we'll talk about a little bit at the end of the semester, by the way. Talk a little about Kepler's motion, Kepler's laws of planetary orbits. And I'm going to land on the moon. Do I really need to be within 8 decimal places of precision? Probably not, because the moon's pretty damn big. Another way that I like to think about this is, let's say that I'm talking to somebody in, I don't know, Benning. And I'm trying to describe my location right now. If I say I'm on the campus of UALR, well, that person in Benton can certainly find UALR. But it's a pretty big campus. It's going to be hard to pinpoint my location. So that might be your whole number of accuracy. In this case, our 3. So our 3 represents the campus of UALR. Well, my next order of precision, my 0.6 here in this case, perhaps that represents the next smaller chunk that I can describe to my visitor from Benton. I'm in the physics building. Okay. Well, using this information, that person can now come from Benton, can look up a map or whatever he needs to do. He can certainly find your campus, and he can certainly find the physics building. This is a somewhat large building. We got a couple floors, several classrooms. How is he going to find me? He needs to know what classroom I'm in. So we're going to use that 3rd decimal precision. This is the classroom. So if I say that I'm in your campus physics building, room 101, you walked in this classroom. There's me and one other student in the classroom right now, by the way. And she does not look at all like me, which she's probably eternally grateful for. You're going to be able to pick me out. You're going to be able to find me. What if, though, this classroom is full? What if this classroom has 100 students? And you had no idea what I looked like. And I ask you to find me. Well, I give you the same level of precision and coordinates. You could come down to this room, but now you need another level of granularity. You need to know about perhaps the row I'm on, perhaps the seat. So every level of granularity gives you effectively 1 more decimal place. So if that helps you, think about that. Think about how we're organizing these units. Your first labs next week and the homework assignments that are going to be due next week are posted already on the website, and they're open to you right now. So you don't have to wait until next week to start doing this. You can jump on there and start doing it now if you want to. In fact, I would encourage you to do that because it gives you the maximum amount of time to kind of play with the material. You don't have to complete the assignments all in one sitting. If you want to sit down and start working them, do a problem or 2 tonight, read the book a little bit, come back, do another couple. That's okay. That's actually the best way to do this course. You are not going to be able to absorb all this information in one sitting. I promise you that. It has taken me years and years of study to get to the point where I'm knowledgeable enough about it that I can teach it. And even then, I'm going to screw up sometimes. So it's okay. Take your time. So this is the kind of thing that you're going to see in the lab starting next week and on the homework assignments. Is we're going to start looking at unit conversion. We're going to start looking at measurement. Pay careful attention to the units. As I said, let's say I gave you something like this in a physics lab, and I said, tell me how long this pencil is in millimeters. And the only thing I give you is a standard ruler that you can buy at Walmart. Well, what you're going to end up doing is taking that pencil, you're going to measure it probably in inches, maybe in centimeters. Whatever you can do, right? Whatever instrumentation you're given. And you're going to have to run some unit conversion. Sometimes you're going to have to guess. Now, I'm not saying just crazy guess, right? You're going to be doing some measurements, and sometimes you're going to run into things that you're going to go, that's somewhere between 3.6 and 3.7 millimeters. Okay. So we can guess on that third, right? But we know that third value is going to be somewhere between 0 and 9. Better be, right? Or we've broken something. Maybe the laws of physics open up a wormhole or something, which would be extraordinarily bad based on every science fiction film I've ever seen. So those are the skills that you're going to practice there. Also, start thinking about the numbers you get when you do these calculations. Do not accept what the calculator spit out just because that's the number the calculator spit out. I see this over and over again. You are going to make this mistake in the lab. This is why we have labs. You are going to make the mistake in the homework, and that's why we have homeworks. Let's say, for example, that in our conversion exercise here, instead of using 100 centimeters per meter, what if I got stupid when I was punching things into my calculator and I fat fingered it and I put 10 centimeters per meter instead of 100? Well, that's going to change my outcome. Instead of being 3.6, I'm going to get 36.0 per meters. I know you're probably not used to thinking about things in meters, but that's one of the reasons that I do this very simple unit conversion on the first day, because everybody, I think, kind of has a good gauge of what 10 feet looks like. If not, do this with 6 feet. I'm about 6 feet tall. Your average male humanoid is about 6 feet tall. So you can kind of gauge that, right? And you can work this out. And if you do 6 feet, it ends up being something like 1.7 meters or something. So using that as a reference, you can start thinking about, does this number make sense? If I know 10 feet is 3.6 meters, or 1 meter is about 3 yards. Everybody's probably seen a yardstick. A yard and a meter are not the same thing. They're very, very close, though. You can use that as sort of a gauge of how close you are. So if you want to imagine what a meter looks like, think about a yardstick. It's about a meter. So if I said, hey, this swimming pool is 10 feet deep, you can kind of visualize that. If I said, oh, the swimming pool is 3.6 meters deep, now you can visualize that. But if I ask you to calculate the depth of the swimming pool at its 10-foot mark, and like I said, maybe you made this little screw up and you put 10 centimeters instead of 100 there, you'd say, oh, this is 36 meters. So imagine your yardstick and stack 36 of them high. That's probably wrong if you try to envision our swimming pool there. That's probably wrong. So use the homeworks and the labs to get used to thinking like that and get used to checking your answers. Take your time, slow down, check your work, and do the sanity check. At the end of the day, does this make sense? When we start talking about velocities, this is where you're going to run into it a lot. You're going to run into things where you're going to be asked to calculate the velocity of something in meters per second. But you're going to forget that the scale of your distance is in millimeters. So you're going to end up being a factor of 100 off. So what you're going to end up with is something that's, you may measure a car on an air track, And you're gonna end up looking at something that's going, 300 meters per second. That's pretty damn fast. So think about how fast 300 meters per second is. Again, think about a yardstick. So take 300 of those, put them end to end. And imagine running so fast that you can go from one end to the other in 1 second. That's not going to work. That makes no sense unless you're the Flash or Superman or something. So that makes no sense. Usually when you end up with a problem like that, and you find out that you made some error in calculation like that, and you're off by a lot, 90% of the time, you're going to be off by a factor of 10. 90% of the time, it means your decimal place is one too far to the left or to the right. If you see that, that gives you a general indication of where to go look in your unit conversion calculations here. So I think I have run my suck enough for today. And I think I have probably filled your head with useless knowledge. So again, go forth, attempt the homeworks, get signed up for the WebAssign, look at my Blackboard. I will post this lecture sometime probably in the next couple of days. I think what I'm going to do is publish them on an unpublished channel on YouTube, and I will provide you the links on Blackboard. And I will also start posting notes on the Blackboard that come from the course material with the book for you to look at. And as usual, if you need help, reach out to me, send me an email, stop by my office, and I will take however long it takes for you to understand what's going on here. Okay. Does anybody have any questions before I stop? Nobody online? Okay, then. I will be doing this again on Friday at 1 o'clock. Those of you that normally would have a lab scheduled during that time, I don't think you'll have one on Friday. So you're welcome to show up here, Physics Building 101 for the next lecture. And the next time we will continue talking about unit conversions and scientific notation. So I will see you guys then.